Hi everyone, welcome to my new video in my Mathematics Essentials series. Okay, so in this video I want to talk about cast diagrams, C-A-S-T diagrams. Okay, and I won't say too much about why we need to learn about cast diagrams, other than to tell you that they are very useful in calculating the value of trigonometric functions without a calculator. Okay, so what is a cast diagram? Well, I'm going to draw a Cartesian plane. Actually, I'll draw a unit circle first. Okay, so here's our unit circle. Here's our x-axis and our y-axis of the Cartesian plane. It's x and that's y. Okay, and we know that for any point on the unit circle, its coordinates are going to be x and y. But we also know that according to our unit circle definitions of trigonometric functions, that boils down to x equal to the cosine of theta and y equal to the sine of theta. Okay, now we need to know in which quadrants of the Cartesian plane our trigonometric functions are positive and negative. So what we are going to do is consider the different quadrants. So here's one, second, the third, and the fourth quadrant of our Cartesian plane. And we are going to ask in each quadrant whether the values of cosine and theta and tan, whether the values of cosine, sine, and tangent of theta, respectively, are positive or negative. Okay, so let's build a cast diagram. And once we've built it and understood it, we can use it in the future to solve problems. So we're going to build the cast diagram on a Cartesian plane. And what we're going to do is focus on this quadrant, right? And what we do is ask whether x is positive or negative and whether y is positive or negative. And after we have determined an answer to each, that will tell us whether tan is positive or negative. So notice that in this quadrant, we are dealing with positive values on the x-axis and negative values on the y-axis. Okay, so all of the x values in this quadrant are positive, and since x is equal to the cosine of theta, that tells us that cosine of theta is always going to be positive in this quadrant. So if we took a point on the unit circle that has coordinates cosine of theta and y of theta, cosine of theta and sine of theta, okay, we know that its x component, which is just cos, is going to be something positive, and its y component, which is just sine, is going to be something negative. All right. Now, tan of theta is just sine over cos, right, which will just give us something negative over something positive. So tan of theta being equal to sine theta over cosine of theta. Once we've done this reasoning for one quadrant, we've pretty much done it for all of them. Okay. So we know that in this quadrant, that's just y, so it's going to be negative, and that is just x, which we know is positive. So it's going to be something negative over something positive, which is going to give us something negative, right? So sine of theta and tan of theta are negative in that quadrant, and cos is the only positive one, which means we write a C to say that this is the cosine positive quadrant, and that sine and tan, that the other two trigonometric functions are negative in this quadrant. Let's consider this quadrant. Okay, well, in this quadrant, x and y are positive. We're dealing with positive values on the x-axis and positive values on the y-axis. So cosine of theta and sine of theta are going to be positive. Tan of theta will just be a positive divided by a positive, so tan of theta will be positive as well. So what we do is we write an A in this quadrant to say that all three of our trigonometric functions are positive in this quadrant. Okay, now let's consider this quadrant. Well, in this quadrant here, all right, we are dealing with negative x values because we are to the left of 0 on the x-axis, but we are upwards from 0 on the y-axis, so we are dealing with positive y values. So that means that cosine of theta is going to be negative in this quadrant, and that the sine of theta is going to be positive in this quadrant, okay? And the tan of theta will just be sine over cos. Sine will be positive, cos will be negative, so tan of theta will be negative, all right? So in other words, only sine is positive in this quadrant. Cos is negative, and tan is negative. So we will write an S in this quadrant. Now we will consider what we should put in this quadrant, and the title, cast diagram, diagram, probably gives it away, but let's do it anyways. In this quadrant here, we know that we are dealing with negative x values and negative y values. So we know that cosine, which is just x, will be negative, and we know that sine, which is just y, will also be negative, but tan will be sine divided by cos, which will be something negative divided by something negative, which will become positive. So tan of theta in this quadrant is going to be positive. Cast. So we write, color consistency. We write a T in this quadrant to say that tan of theta is the only positive trigonometric function of those three in this quadrant. So this is a cast diagram. A cast diagram tells us that in the x positive quadrant and y negative quadrant, only cosine is positive and tan and sine are negative. Okay, in the positive x and y quadrant, all of our trigonometric functions are positive. All right, in the x negative and y positive quadrant, sine of theta is our only positive trigonometric function of the three that we're talking about, and the other two are negative. And in the x negative and y negative quadrant, okay, only tan is positive, whilst the other two are negative. So that's cast diagrams, and they are going to be quite useful later. If you found this video helpful, please give it a like, feel free to share it with your friends, and if you'd like a notification when I upload a new video, subscribe to my channel. Until next time, bye for now.